Alright guys, so this should be group 2 on decomposition. And so as you learned on Friday, decomposition is a type of reaction in which you take one reactant and you break it down into more than one product, okay? And so when you hear that word decomposition, you can kind of think about like if your food, maybe on the counter and the fridge starts going bad, it's decomposing or breaking down, okay? So in decomposition, that's the exact thing that's happening, is you're taking kind of one compound and breaking it down, okay? And so that's kind of the characteristic sign of a decomposition reaction, one compound on the left being broken down into more than one compound on the product side on the right, okay? And so the nice thing about decomposition reactions is that they're kind of a pretty well-defined set of rules that govern what products you'll form when you break down a certain type of compound, okay? Now this section is really straightforward as long as you can get your classmates to use the rules that are found at the top of your blue reference sheet, okay? Now my experience in the past has been that oftentimes even though students are shown, how to use the rules, they try to do these reactions without them, which creates a lot of difficulties. So your main thing is, trying to get the message across that, hey, you really need to use the rules. They make it very, straightforward, okay? And so basically what I'm going to do is I'm going to walk you through an example of kind of each of the 5 rules, and then that way y'all can use those, as you're kind of teaching your classmates. Now, as you're kind of reading through the rules, you're going to notice that there are a few words that kind of, reoccur. So you'll see words like maybe metals, okay? And so it'll be important to, remember that metals are typically on your left side of the periodic table. And you'll also see words like non-metals come up. And so remember that your non-metals are typically on your right side of your periodic table, okay? And then you'll also hear some references to polyatomic ions like carbonate and chlorate. So in your 8s, you're still going to look on your polyatomic sheet. And then you'll additionally see some references to single elements like oxide referring to oxygen, chloride referring to chlorine. So it's important that you've got, just kind of your chemistry language going. That way you can interpret what the rules are saying. Okay, so now let's get to it, and we'll start off with an example for number 1. And so basically, you just read the rule and follow what it says. Okay, so here's my example for us, and I'm actually going to start by just writing out the rule. So it says that you start with a base, and in parentheses it tells you that what a base looks like is it's a metal hydroxide. So that means you've got a metal and then the polyatomic ion hydroxide. And it says when it's heated, it will break down into a metal oxide, okay, plus water. Okay. So what I'm going to do is I'm going to kind of give you a metal hydroxide, and then you're going to be required to predict the products for it. So let's just start off, and let's say we've got calcium hydroxide. And so I need 2 hydroxides to balance out the +2 charge on calcium. So here's my metal hydroxide. And so if we follow the rules, it tells us that what we should make is a metal oxide and water. So I already know what water looks like off the top of my head, so I'm just going to go ahead and pencil in H2O. Okay? Then all that leaves me to do is form my metal oxide. So you just look back at your reactant and you see that your metal is calcium, and then oxide refers you to oxygen. Okay? Now the catch is, just like we've been practicing in nomenclature, you want to put together your metal oxide so that your charges balance out. Okay? So in this case, calcium is a 2+, oxygen is a 2-, so I just need 1 of each. Okay? So overall, my reaction is calcium hydroxide yields calcium oxide plus water. Okay? And then, like always, you want to go back and just make sure that your reaction is balanced. Okay, so I've got 1 calcium on either side, 2 oxygens on each side, and I've got 2 hydrogens, so it looks like I'm good to go on my balancing. All right, so there's kind of your first example. And so now let's do an example for our second rule that says an acid, when heated, decomposes into a into a non-metal oxide plus water. And I'm realizing that I kind of forgot to tell y'all what the symbol for heated looks like, since that applied to number 1 and number 2. So what you're going to look for that is a little kind of triangle, and that just indicates that heat has been applied. So now we're going to have an acid being heated, and it breaks down into a non-metal oxide plus water. So again, I'll start off and give you an acid, and then we'll use the rule to write the products. Okay, so an acid, I'll just kind of pick one for us. So let's do carbonic acid. Okay, so it's going to be heated. And so my rule says that it'll break down into a non-metal oxide and water. So I already know what water is, so I'm going to write that in as H2O. Okay, so now I need to write my non-metal oxide. So my non-metal in this particular case is I'm working with carbon, okay? And so what you're going to do is, if you look at your decomposition rules, they have this phrase kind of after the title that says use the gas ion chart. Okay, so on your blue reference sheet, the gas ion chart is directly below your decomposition rules. Okay, and what it's going to help you do is it's going to help you figure out kind of your non-metal oxide based on what ion you started with. Okay, so here I was starting with carbonate, and so what it shows me is that my non-metal oxide will be carbon dioxide. Okay, and so it kind of makes sense because here I've already used up 1 oxygen in my water, so I should technically only have kind of 2 left from my carbonate. Alright, so that's how you determine kind of what your non-metal oxide should be, is by using your gas ion chart. Alright, and so then at the end you just go back and balance. So I've got 2 hydrogens on either side, 1 carbon on either side, and I've got 3 oxygens on either side. So this one also looks kind of already balanced or good to go. Alright, so now let's move on to our third example. So rule number 3. Okay, so what this one says is that if you take a metallic carbonate, okay, it should break down into a metal oxide and carbon dioxide. Okay, so again, I'll give you the reactant, and then you need to predict the products using the rule. So let's say that our metallic carbonate, let's say we've got sodium carbonate here. Okay, so again, here's our metal, and then the carbonate, I knew that from my polyatomic ion sheet. Okay, and so now my rules tell me that it should break down into a metal oxide. So I know I'm going to need my metal, sodium, and then I'll need oxygen for oxide. And it tells me that I'm going to form carbon dioxide. Okay, and from my covalent nomenclature, I know that that's just C, carbon, O2 for dioxide. So my last step is just to piece together my metal oxide using charge balance. So I know sodium is +1, oxygen is -2, so it should take me 2 sodiums to balance out 1 oxygen. Okay? And now guys, when you're teaching, another big thing that you have to emphasize to your classmates is when they're forming their metal oxide, they need to come over to the side, balance out the charges, then go back and plug in the product. Okay? So that's the catch there. So you need to have them do charge balance before writing their product. Okay. So last but not least, check and see if it's balanced. In this case, it is. And oftentimes that is one nice thing about decomposition, is that a lot of them do end up working out to be balanced. Not all the time, but a lot of them do, which is nice. All right, so now let's tackle rule number 4, which says a metallic chlorate decomposes into a metallic chloride and oxygen. So again, I'm just going to write my rule. So it says a metallic chlorate decomposes into a metallic chloride plus oxygen. Okay, so again, I'll provide the reactant and then you guys will give me the products. So my metallic chlorate, let's see what metal do we want to go with this time. So let's just pick potassium maybe. And then again, chlorate is my polyatomic ion, ClO3. Okay. So then, what my rule says is that I should break it down into a metal chloride and oxygen. So I already know oxygen is O2. Remember, it's one of our diatomic elements. Be careful about that. It's not just O, but O2. And then I need to come back and form my metallic chloride. So again, you've got to get your classmates to come kind of to the side and balance it out. So take your metal potassium, and then you take chlorine from chloride. Potassium's a +1, chlorine's a -1. Balance them out, KCl, and there's your product. Put it in red here. Okay, so here's my metallic chlorate breaking down into a metallic chloride and oxygen. And again, let's check and see if it's balanced. In this case, it does look like we're already balanced and good to go. All right, then last but not least, one more rule to work through. So let's look back at rule number 5 for me. Frozen up here. Okay, over here maybe. Okay, so I've got rule 5 at least on my sheet. Pause right quick, get this off. Alright, we're back again. Sorry about that. So rule 5 says that some compounds decompose with electricity or just simply decompose into their elements. Okay. And so basically what this is kind of keying you in is that if you start with just one reactant and it doesn't match one of the descriptions from rules number 1 through 4, then it's going to fall into this 5th category where you just take the compound and break it back up into its kind of individual